Next, may I invite Mr. Dominic Williams, founder and chief scientist of the DFINITY Foundation, on stage to share with us his presentation. Ladies and gentlemen, please join me in welcoming Dominic. Dominic, please.
Hello, everyone. Hi. If you don't know me, I'm Dominic. I'm the founder and chief scientist of DFINITY, and we the main technical contributor to something called the Internet Computer Blockchain. First of all, just like to thank Dr. Xiao and Wangsheng and Hashki for having us here. Thank you. So without further ado, let's go through this. So something you may find interesting is you can find this deck on this URL. So if you take this QR code, you get a URL, and it takes you to a copy of this deck that's being served from the blockchain. So that's because the Internet Computer Blockchain can process HTTP. So it's the first blockchain in the world that can create a user experience. So you can build things on the Internet Computer that serve their own user experience. You might be wondering, how much does that cost? Because decks are pretty big. How much does it cost to store a deck on the blockchain? And the answer here is actually not that much. And it's about 4 cents a year currently to store this deck on the Internet Computer Blockchain. And that's an absolutely incredible improvement in efficiency. So to give you some comparables, it would cost you about $800 to store this on Solana. And it would cost you almost $500,000 to store this deck on Ethereum. But of course, these chains also couldn't serve it. So you're probably guessing this is a Web3 chain. Funnily enough, this deck is slightly out of date. And I realized that when I opened it. And for that reason, it says that the blockchain's processed 1.25 billion blocks. But if you go to dashboard.internetcomputer.org, you can see that today it's processed about 1.9 billion blocks. 1.9 billion. So a huge number. Another interesting stat is that today it's doing about 5,500 transactions a second. But those transactions do an awful lot more compute than a traditional blockchain transaction. So it's doing the equivalent of about 250,000 Ethereum transactions a second. 250,000 Ethereum transactions a second when you compare EVM instructions to WASM instructions. It's got a different virtual machine. So the aim of the Internet Computer is to enable something we describe as blockchain singularity. And it's this idea that blockchain will replace traditional technology, so that in the future, people will actually build on a blockchain rather than building on the traditional technology stack, using things like Amazon Web Services. So something very different. The name DFINITY, of course, comes from a concatenation of decentralized infinity. DFINITY itself is a not-for-profit foundation based in Switzerland. Actually the biggest R&D operation in blockchain, and have been for a while. We have probably the biggest team of well-known cryptographers in the world, bigger than Google, bigger than some security agencies. And the Internet Computer is really, conceived as something first and foremost that can replace traditional technology, but also fixes a lot of key problems for Web3. So, if you look at the prevalent architecture today, you have a blockchain that stores some tokens some NFTs maybe, or links to, the NFTs are just links to data on Amazon. And really everything lives on Amazon, right? So today's Web3 is, you have like the 99.99% of data and computation lives on Amazon Web Services. And this presents some problems because if users want to own a service, if they want to have governance tokens in the service, it doesn't really work because a DAO can't control something that's running on Amazon Web Services. A DAO can only control smart contracts on the blockchain. So, this is generally where things go wrong. Hackers, regulators, censors, they all head to this centralized technology. And our solution is, just put the world on chain. The internet computer is a blockchain that can act as an alternative to traditional platforms like Amazon Web Services. So here is the internet computer. As a sort of schematic, this is what it looks like. Down the bottom, you've got these node machines that are combined by this thing called ICP, the Internet Computer Protocol, and they're formed into essentially an infinitely scalable blockchain with very, very high efficiency called the internet computer. Without getting into the details, it involves a lot of very sophisticated math, a lot of it kind of pretty breakthrough in nature. So I mentioned, there are a number of differences between the internet computer and traditional blockchains, and these go beyond just speed and efficiency. One of the key ones is that smart contracts that you install on the internet computer can serve web. They can actually process HTTP requests and serve a user experience. So, here we've got some users on their phones, on their laptops, and they're interacting with a Web3 service running on the internet computer. And there's no intermediary. There's no Amazon Web Services. The whole thing is built with smart contracts. Let's go. Yeah. So one of the very cool things that you can do, if you can build a service entirely on the blockchain, is you can put it under the control of a DAO. Now you hear a lot of talk about DAOs today, but generally speaking, they're social constructs. Somebody puts a proposal in, people vote on the proposals, and then there's a developer who has to go away, and he has a private key, and he updates the service. But with this system, the DAO can actually be in control. So the DAO updates the software of the service itself and gives users ownership and makes the whole thing much more secure. We've got another technology on the internet computer. It's called chain key. And this enables smart contracts on the internet computer to create transactions on other blockchains. So you can create code on the internet computer that can initiate transactions, for example, on Bitcoin. So the internet computer is able to create transactions on other blockchains without having a private key. It's using a new kind of cryptography called chain key. We've already got thousands of people building very, very interesting things on the internet computer. And most of them are pursuing this model where Web3 services become DAOs. They actually become DAOs. And on the internet computer, you can build a social network. There are projects now with hundreds of thousands of users on the internet computer. There's no Amazon Web Services. All of the content is on the internet computer. All of the data processing happens on the internet computer. The user experience is on the internet computer. So it's blockchain end to end. So something else very cool about the internet computer is that it's controlled by a DAO. It's called the network nervous system. And this thing is essentially controls these node machines that make up the network. The network itself is created by dedicated hardware. So it's a bit like, with Bitcoin, you have ASICs, right? Like mining rigs. And these mining rigs together create the Bitcoin blockchain. In a similar way, these devices called node machines combine with ICP and create the Internet Computer blockchain. And all of these machines run under the control of this thing called the network nervous system. You got this kind of platform, which is a blockchain, but one that can run smart contracts at any scale with incredible efficiency, incredible speed, that can process HTTP. But you don't lose any of these fantastic properties you get with a blockchain. So that means that you still get security, you still get liveness, you can still make your code autonomous. But the interesting thing here is that the efficiency of the Internet Computer blockchain is approaching traditional IT. And our target is to actually have a blockchain that can provide a complete alternative to traditional technology platforms like Amazon Web Services, but actually produce less CO2, actually be more efficient than traditional tech. So these improvements obviously are enormous. And so going back now to the cost of storage. So this compares the cost of storage, like smart contract memory, on Ethereum and Solana, and the ratio is about 1 to 650. So if we zoom into Solana and then do the comparison, we can see that it's a further 1 to 23,500. So to put it in perspective, the Internet Computer is millions of times more efficient than Ethereum. And that's why you can build a social network that actually runs from the blockchain. Putting it into real world terms, it costs you about 1.6 cents currently to upload a photograph onto the Internet Computer blockchain. It costs you about $400 with Solana, and it's not really even technically possible. So if anybody's curious about what you can actually build, I always like this example. It's called OpenChat. Take the QR code. It's a chat service that runs on the Internet Computer. And it's interesting because it's an early example of social fi. And social fi is a new trend in Web3 where you have a service, like a social media service, that at the same time can blend with DeFi. So in fact, when you go into this chat service, which is served into the browser, your chat account is also a crypto wallet. And just generally, I invite everyone to explore the Internet Computer ecosystem, because there are people working on equivalents of almost every single Web 2 service. You can do video streaming from the blockchain, for example. A lot of activity on GitHub, and there's a sort of bigger picture here as well, which is there's a general trend, which is that we're moving into a world where we're going to use these decentralized systems as our primary platforms. So, I said that blockchain is going to kind of eat cloud. Blockchain is going to eat cloud, and there's an expression in Silicon Valley that software is eating the world. And I think our view is that software will smart contracts will eat software. So, if we scroll forward 5 years from now, most services will be being built with smart contracts. Like when you build a social network, a Web3 social network, or the back end for a metaverse experience, You're not going to be coding it on Amazon Web Services. You're not going to be using a database. You're not going to be using a web server. You're going to be building the entire system end-to-end on the blockchain. There's also, a kind of big business opportunity more generally here. It's kind of bigger than blockchain. So every year, like last year, 2022, the world spent about $500 billion on the way to $500 billion on cloud services. $500 billion on cloud services. Now, potentially, with the Internet Computer blockchain, you don't need a cloud service anymore. You can just build directly on the Internet Computer. And that gives you some other savings. So last year, the world spent $172 billion on cybersecurity. Things like firewalls, SIEM logging, security teams. And of course, if you build on a blockchain, you don't need a firewall. That's one of the big advantages. You don't actually need a firewall. Overall, the world spent about $5 trillion on IT last year. It's an awful lot of money. And, our belief is that when the world moves from cloud and builds on blockchain, we're going to reduce CO2 emissions, obviously greatly reduce the security issues that we face today when we're building on cloud, and just migrate onto a platform that will allow us to just fundamentally reimagine the internet, how enterprise systems work. And if you scroll forward, a few years, even in 5 years, we think the majority of startups in the sort of internet service space will in fact be DAOs. Like, if you're creating a new service, it's going to be a DAO. And very likely, you're going to raise money using governance tokens. You're going to distribute the governance tokens to a community. But also within the enterprise space, we believe that enterprise systems will also be DAOs, because it doesn't make sense to give one developer in your organization a key that they can use to update your entire corporation's enterprise systems. So enterprises, too, will actually create the enterprise systems as DAOs and use them to distribute control. So this is a technical slide, but there's a lot of very interesting features. If anybody here is more technical and actually building Web3, who is building Web3 services? Actually got in. Okay. Yeah, so we got a fair number of people. There you go, actually building Web3 services. So, there's a lot to understand with the Internet Computer. It's a very different kind of platform, and there are a lot of kind of capabilities and features that you haven't seen before, like reverse gas, HTTPS out calls, chain key, all these things. But if you're building a Web3 today, I very much recommend that you look at the Internet Computer, have a go, experiment, and then ask yourself the question, do you really want to be building on Amazon Web Services? Is the future of Web3 on Amazon Web Services? I'd say it's not. The future of Web3 is on the blockchain. And for that reason, I recommend you have a good look. For those of you that are just blockchain enthusiasts, maybe not building anything right now, the Internet Computer is not a particularly well-known project, but it's the biggest R&D project in blockchain. And it's been the biggest R&D project since sort of 2017, 2018. So there's a huge amount of technical momentum in this project. And again, I invite you to investigate, get involved with the community, and help us drive awareness. Okay. All right. Thanks very much.
Thank you. Thank you, Dominic, for the wonderful sharing. Thank you.